Ladies and gentlemen, we're going to redo question 3 from Fall 21, Test 4, Part 1. And we're going to take it from the top. We already saw that we're starting with this molecule here. And it's S. And 1, 2, 3 to 4. Okay, so the reaction 1, given the information at on the top of the screen, if I could write properly, PCl5 does this. You get an alkyl chloride with the stereocenter flipped. So it used to be S. Yes, it's now R. And now we're going to do an SN1 reaction. We're actually told it's an SN1. So as soon as you throw water in there, nothing happens. You're also told that heat is required because the reaction's too darn slow. And here's the first step in the mechanism. What are you going to generate during this SN1, during this slow first step in the mechanism? Okay, I need to know the organic piece. The Cl- is just leaving group. It's gone. It's history. I didn't indoctrinate you well enough because I just asked, what is the key intermediate in this SN1 reaction? And I've waited for more than 10 seconds for you to say carbocation. This is not good. Okay, carbocation. What category of carbocation is this? Secondary. Name 3 categories of carbocation that are better than secondary. Well, you know one, obviously, from like last test, you knew that there's one carbocation that's better than secondary, and it is tertiary. Now I'm going to tell you that there are cations even better than tertiary, like secondary allylic. This is not news to you. On our notes from Monday, it says there's something more important than hyperconjugation. What was it? Resonance. And you can do resonance to a carbocation if you're allylic. The stability increases by 0.5 over your original number. I will explain that in 2 seconds. If you move this H to here, you have generated a superior cation that is called secondary allylic. It can resonate. That's why it's so easy to make 2 equally stable resonance forms. It won't let me draw a cation there. There, cation. Okay. So no matter which resonance form you choose, your alcohol ends up where your cation was, sorry. And you get this, and it was an SN1 reaction, so talk to me about stereocenter. 50-50 RS. You'll notice I purposefully avoid using the word enantiomers in case there's a diastereomer issue, and then my memorizing got me because what you're about to say something wrong. If there was 2 stereocenters, you'd make a 50-50 mix of 2 diastereomers, not enantiomers. But I know there's only one stereoisomer here, so yes, your answer was cool. She said a 50-50 mix of enantiomers. So that is just step 2, people. That is the end of step 2. Okay? 2 reacts to give that. Phosphorus pentachloride reacts to give this. Each stereocenter being flipped every time it reacts. But, you know, You get 50/50 RS becomes 50/50 SR. How's that? Trying to show you it's flipped still, but doesn't matter. 50/50 RS, same as 50/50 SR. And now it's sodium azide. 50/50 azide. And 50/50 to the amine. But it is not the amine on carbon with alkene on 3 to 4, it's 2 to 3. That was where our mistake was made. 50/50, 1, 2, 3, cyclohex 2-ene 1 amine. So we're going to go back to our, we're not going to update our drivers. We're going to close this. Cyclohex 2-ene 1 amine, get rid of all those nasty comments about error on key. Yeah, things were looking pretty dire. Okay, the 2 amines, yeah, 50/50 mix of 1 and 2, correct? And that was AE, which was correct all along. My apologies. My apologies. Okay, and we already had the AD from before here. And that's that. I hope.